Okay, so I have to warn you, today's video is a bit more tricky. It might take you like or maybe you'll have to watch this video again just to understand what I'm saying. But what I'm saying today is going to be extremely important for you to understand, because it's a building block of what functions are and how to work with functions later. So it might seem very obvious. So I'm going to repeat it twice, and then we're going to look at what this means for us. So in the previous videos, we drew these lines. And let's just forget about these lines. Let's just take in general. I did say this before, but you should kind of understand this. If I look at the y-intercept, anywhere on the y-intercept, if I wrote there y-intercept, maybe I can write it as on the y-intercept, all x values is equal to, I wonder. So if I'm on the y-intercept here, what's the y value? It's 4, obviously. But what's the x value? Oh, it's 0. And if I go here, what is the x value here? It's always 0. So no matter where on this line I go, all the x values on the y-intercept will also always be 0. And the opposite is also true for the x-intercept. So if I wrote on the x-intercept, all y values would be equal to, I wonder, let's take a look. So if I had a coordinate here, its x-coordinate would be 4, but what would the y-coordinate be? Well, I have to go to the y-axis and see, it's 0. Oh, oops. Or if I look here, the y value will always be 0. Everywhere on this line, the y value would be 0. So, very important to understand. Anywhere on this y-axis, the x values would be 0. And anywhere on the x-axis, the y values would be 0. Now, with this very important information, we can use a trick to draw graphs in a different way. Now, with this information, let's just take a look at our first example, or not like, let's just take a look at this example. Oh, wait. Didn't I write the equation? Oh, well. Let's just write it here anyway. So here I have y is equal to, this one I remember is x plus 1. But now, looking at this information, I can say, you guys remember this was a function, so there was an input that gave us an output. So if my input value for x is something, then it will give me a different output value. So, but what I do know is if I put 0 as my x value, I would get the y-intercept, right? Because all x values that are equal to 0 will give me the y-intercept. So for the y-intercept, make x equal to 0. So if I put in y is equal to 0 plus 1, I would get y is plus 1. And we saw from the previous video that's just the c value, right? And if I look here, y is equal to 1. If I go to my graph that I drew, then I see, oh, that's the y-intercept. So I made x 0 to get my y-intercept. And now I can do kind of something else as well. I can do kind of the opposite. I can do for the x-intercept, make y equal to 0. Because I know if I get my y value 0, then I get my x-intercept. Now, this is kind of just doing it backwards. So if I had a spider and we had, I just call it a spider diagram. I'm sure it may be called something else. In this case, I'm going to do this one in black. In this case, we said make x 0, and then we got an output of 1. But in this example, I'm kind of doing it backwards. I'm saying, okay, let's make our output 0. What input do we need to get our y 0? So what I do is, this 0 is my y, that's my x. So I make 0 is equal to x plus 1. And then I can just rearrange the formula, and I can take, well, let's say I take away 1 on each side, or I move the 1 over. It can be -1 is equal to x, or x is equal to -1. So, okay, I should have done that here, but pretty much that's what happened. For the x-intercept, make y 0, and now I see, oh, x is -1. And if I go look at the graph that I drew earlier, if I go look at the x value of -1, then I see it cuts or intercepts the x value exactly where I predicted. So if I had a blank graph, hopefully I have one left, and I just went with these 2 points, y being 1 and x being -1, then I could draw the line because I have 2 points. So that's a very easy way of doing it. Let's look at our other example that we had just to make sure, and then we'll do a new kind of, let's do a new one as well, but we'll just go over one we already did. So I'm just quickly gonna write, just take this out. Gonna keep this there because that is very, very important. It is very important. It is importanter. No, I'm just kidding. It's very, very important. Okay. Let's write the equation we used last time. So y is equal to a half x minus 1. And I can say for my y-intercept, make x equal to 0. And then I do y is equal to a half times 0 minus 1, and then y is -1. And then for my x-intercept, make y equal to 0. So then 0 equal to a half x minus 1. Take that over, so I have 1 is equal to a half x. But I don't want a half x, so I multiply with 2 on both sides. So then I get 2 is equal to x, or x is equal to 2. That looks nicer. So if I go and look here, did I tell you the truth? So y -1, y -1 there, it's on our line. And then x is equal to 2 there. And then if I just connected those 2 dots, then I would have my straight line. So this is kind of the double intercept method, where we make x value 0 to get our y-intercept, and we make our y value 0 to get our x-intercept. So let's do just any different example. I'm going to think of one now, and then we'll draw it using our newly learned method. So I'll put the blank one here. You can maybe try and pause the video and do it yourself. But let's just think about the example first. So let's do, and the beauty of this one is we don't need standard form for it. But let's just keep it in standard form just to make it not too difficult. So let's say y is equal to 2x minus 3. So you can pause the video and see if you can figure it out. But I'll quickly do it now. So you know there are 2 other methods of drawing this. We can use the table method, which we did in the previous video, and then also the gradient and the y-intercept method. And then this is the double intercept or x and y-intercept method. And for this one, let's say for y-intercept, make x equal to 0. Now when it's in standard form, it's pretty straightforward. You can just read it off, but just for, let's say, for me doing it thoroughly, I'll kind of do the equation. But when it's in standard form, you just know the y-intercept is -3, but we'll just do it here anyway. So y is 2 times 0, and that would be -3, so y would be -3. So if I go look here, then y is negative 3 over there. Okay. And for the x-intercept, make y equal to 0. So then here I make 0, we can put it in brackets, but it's just saying 0, 2x minus 3. I add 3 on both sides, so I get 3 is equal to 2x. And then I have to divide by 2 on both sides. So I get x is equal to 3 over 2, or x is equal to 3 over 2, which is the same as 1½ So here I'll have to go to x1½ right there, and then I would draw a line. Hopefully get this line right. Right there. Let's go line. Can draw the line there to infinity and beyond. And this is the line. And if I wanted to check it, I can kind of, if I used my gradient method here, I can start at negative 3, which would be there, negative 3. And then this 2, my gradient is 2. So this is just checking. You don't have to do this afterwards. But, well, I would advise doing this afterwards. But later, you'll just see this. You don't have to kind of do it over and over again. M is 2, or it would be the same as 2 over 1. So it means that the rise, I'd have to rise 2 and run 1. So if I rose 2, 1, 2, and I ran 1, I get to the line. So I see that's on the same dot. So it means, well, it works. In the next video, we're going to look at yet more examples.